Hello, girls. I hope you're having a great day and staying safe at home. To continue with alkanes, today we are going to discuss the chemical properties of alkanes. Now, you know methane and ethane, both of which are alkanes, they are saturated hydrocarbons. That means the carbon-carbon bond between them is satisfied by a single bond. So they do not react with bases or with oxidizing agents or with reducing agents. So the only reaction they undergo are combustion and substitution reaction. So methane and ethane, they undergo complete combustion reaction. They burn in air with a bluish non-sooty flame, complete combustion. That means there are no carbon particles also produced. So that is why it is non-sooty. It is blue in color. Okay, and a large amount of heat is given out. So alkanes are good gaseous fuels. So methane and ethane burn in air, that is, they use oxygen to produce carbon dioxide and water vapor. Okay, and remember, both ethane and methane, they have very less carbon content, so they burn with a non-sooty flame. Very less carbon particles will be given out. Of course, remember, we need to balance the equation, so we put 2 here and 2, 7, 4 and 6. Okay, now supposing there is insufficient supply of air, that is, less oxygen reaches when alkanes are burning. Okay, so what do they form? Instead of carbon dioxide, they form carbon monoxide. Okay, and 4 molecules of water. Similarly, ethane also, 2 molecules of ethane react with 5 molecules of oxygen to give 4 molecules of carbon monoxide plus 6 molecules of water. Now this reaction takes place if there is less air, insufficient supply of air, and if there is more, very less oxygen, lesser than this, what will happen? Instead of carbon monoxide or carbon dioxide, carbon will be formed, carbon particles. Okay, and 2 molecules of water. This carbon is known as soot. Okay, soot is used in the manufacture of printing inks and tires. Okay, now next, moving on to substitution reaction, that is, there is a substitution. Okay, exchange. So alkanes react with chlorine, bromine, iodine. Okay, in the presence of sunlight or ultraviolet light to give halogen substituted products, which are known as alkyl halides. So alkyl halide, it contains one or more halogen atoms. Okay, you know what halogens are: fluorine, chlorine, bromine, iodine. So here we are talking about the reaction of alkanes with either chlorine, bromine or iodine, which are halogens. Okay, now methane reacts with chlorine, and what was the condition? Sunlight, and in this case it is diffused, very less sunlight. Okay, diffuse sunlight. Okay, or at 600 Kelvin temperature. So one hydrogen will be removed and chlorine will be added and HCl will be formed. Okay, so to explain it further, this is the structural formula of methane. Okay, and it reacts with chlorine. Chlorine has 2 molecules of chlorine atom Okay, so now there is an exchange. This will come here and this will come here. So what product will you get? You will get C, how many hydrogen? 3, CH3, and then chlorine plus HCl. Okay, so this is known as chloromethane. So in this reaction, the chloromethane form, that is CH3Cl, okay, by the substitution of hydrogen atom of a methane molecule by chlorine atom. I already showed you here. So there is substitution of hydrogen and chlorine. Chlorine takes the place of hydrogen and hydrogen is released to take the place of chlorine here. So this type of reaction is known as substitution reaction and the product formed is known as substitution product. Okay, so the product formed, that is chloromethane, further reacts with chlorine to form dichloromethane. Okay, so here you can see the hydrogen is being replaced by chlorine and this is dichloromethane. The dichloromethane again will react with chlorine. So now again one more hydrogen will be substituted to form trichloromethane, okay, or chloroform. Trichloromethane, which is also known as chloroform. And of course, HCl will be formed. Now the chloroform or trichloromethane will again further react with chlorine to give CCl4. So this one hydrogen is totally substituted to form tetrachloromethane, or you know it as carbon tetrachloride. And carbon tetrachloride is also known as tetrachloromethane. So this substitution products can be separated by fractional distillation. Okay, and ethane also reacts with chlorine in the same way, producing, instead of chloromethane, it will become chloroethane, dichloroethane, trichloroethane, okay, tetrachloroethane. So you can see how ethane reacts with chlorine. First to give one hydrogen is substituted with chlorine, okay, then again monochloroethane with chlorine. From 5 it will become C2H4Cl2 plus HCl. Again C2H4Cl2 plus chlorine. Again one less, so it becomes C2H3Cl3 HCl. Again C2H3Cl3. Again one more will go out, C2H2Cl4 plus HCl. Okay, so we have monochloroethane, dichloroethane, trichloroethane, tetrachloroethane. You can easily deduce the name by looking at the number of chlorine atoms present. Okay. Now tetrachloroethane. Now again one more hydrogen will be removed. So it becomes penta. 5. Pentachloroethane. And pentachloroethane still has one hydrogen which can be substituted. So this is hexachloroethane plus HCl. Now moving on to the decomposition of alkanes. Okay, the decomposition of a compound by heat in the absence of air is known as pyrolysis. And when pyrolysis takes place in alkanes, then it is known as cracking. So cracking and pyrolysis is the same thing, but cracking takes place only in alkanes. Okay, it is heating alkanes in the absence of air. So the alkanes, when we heat under very high temperature or there is some catalyst in the absence of air, they are broken down into lower alkanes. Just see, when we heat methane at 1500 degrees Celsius, it turns into triple bond, means it is ethine, and 3 molecules of hydrogen is given out. Similarly, if we take ethane at 500 degrees Celsius in the presence of a catalyst, aluminum oxide, ethene means double bond, and hydrogen is released. Similarly, pentane, when we heat at 400 to 600 degrees Celsius in the presence of alumina or silica as catalyst, remember, air is absent, propane is formed, and ethene is formed. Okay, similarly, when we take heptane at similar condition, that is 400 to 600 degrees Celsius, and with the same catalyst, alumina and silica, butane is formed. C4H10 butane plus propene is formed. Okay, now in catalytic oxidation of alkenes, that is when oxidation or catalytic oxidation takes place, alkanes will give either alcohols or aldehydes or carboxylic acids. Okay, so it depends on the reaction conditions. So when we take a mixture of methane and oxygen in the ratio 9:1 by volume, and we compress it to 120 atmosphere pressure, okay, and then it is passed over copper tubes at 475 Kelvin. So these are the conditions. Okay, what do we get? We get methyl alcohol, 2 molecules of methyl alcohol. Okay, so again, if we take the same mixture, that is methane and oxygen, when we pass it through heated molybdenum oxide, then this mixture, that is a mixture of methane and oxygen, is oxidized to formaldehyde and water is formed. Okay, again we take the same mixture, methane and oxygen, okay, and we take a manganese based catalyst at 100 degrees Celsius, then we will get formic acid and water. Of course, when you balance it, 2 molecules, 3 molecules of oxygen, 2 molecules of formic acid, and 2 molecules of water. And in the same way, the same type of reaction also takes place for ethane. 2 molecules of ethane with oxygen, okay, 120 atmospheres, copper tubes at 475 Kelvin, we get 2 molecules of ethyl alcohol. Ethane with oxygen, same reaction, but the condition is different. Molybdenum oxide, we get acid aldehyde plus water. Again, so if we take ethyl alcohol and oxygen, okay, in the presence of platinum at 300 degrees Celsius, acetic acid will be formed with water. Now, moving on to slow combustion. Okay, methane or ethane can be treated with oxidizing agents like acidified potassium dichromate or acidified potassium permanganate at very high pressure and very low temperature. So there is a very slow type of combustion taking place. Okay, so if you take any alkane, be it methane or ethane, in the presence of potassium dichromate, okay, and this oxygen is given by the oxidizing agent. First it will convert into alcohol, again by potassium dichromate it will turn into aldehyde, okay, further aldehyde, again the nascent oxygen is given by the oxidizing agent potassium dichromate, okay, and aldehyde will turn into carboxylic acid, which finally will turn into carbon dioxide and water vapor. So this is slow combustion. Alkanes turns into alcohol first, alcohol will turn into aldehyde, aldehyde will turn into carboxylic acid, which will finally turn into carbon dioxide and water. Okay, you can see if we take methane, it turns into methyl alcohol first. Okay, in the presence of nascent oxygen given by potassium dichromate, then it will turn into formaldehyde, formaldehyde. Further, again, there is nascent oxygen coming from the oxidizing agent, that is potassium dichromate. It will turn into formic acid, okay, which will further be oxidized into carbon dioxide and water. So this is slow combustion, okay. Other alkanes also form similar products when they react with oxidizing agent. So finally we come to the uses of methane. So it is a source of carbon monoxide and hydrogen, okay. It is used in the preparation of ethine, methanol, chloromethane, tetramethane, okay. And earlier, chloroform was used as anesthesia, but since its higher dose could kill a people, so nowadays it is halothane, that is CF3CHBrCl. This is used as the anesthesia these days, okay, halothane, and it is also used as domestic fuel. Now, coming to ethane, the uses of ethane. Ethane is used in the preparation of ethene, ethanol, ethanal, ethanoic acid or acetic acid. It forms ethyl chloride, which is used to make tetraethyl lead. Okay, it is a solvent that is used in dry cleaning, and ethane is also a good fuel. So with this, we come to the end of alkanes chapter. Please go through the chapter as well after you go through this video. Till then, stay safe, children. Have a good day. God bless you.